Introduction to Kubernetes. Let's discuss briefly about the history of Kubernetes. Google uses Docker containers to run all its applications. To manage Docker containers running at cloud scale, Google developed a container management platform called Borg. Kubernetes is an offspring of the Borg project. Google donated Kubernetes to the open source community. Kubernetes is widely popular in the industry because Google supports it. All cloud providers, including AWS, Microsoft Azure, and IBM Cloud, support Kubernetes in their cloud. Why did Google open source Kubernetes? The answer is, according to Canalys, a market research firm, Google has a very low market share in the cloud infrastructure service market. Google makes roughly 700 million US dollars in annual revenue from the cloud business, while Amazon Web Services makes 3.5 billion US dollars in annual revenue. Google wants to gain popularity and market share in the cloud business. Google knows that Docker containers are becoming widely popular across the industry. Hence, Google open sourced Kubernetes to attract customers who want to run and manage Docker containers in the cloud. Google expects to gain more market share in the cloud infrastructure services market by giving away Kubernetes for free. What is Kubernetes? Kubernetes is a container management and orchestration platform. Kubernetes is also a cluster management platform. Clusters are nothing but a large number of servers connected together to run containers in them. Kubernetes is not a containerization platform like Docker or LXC. Kubernetes is not an alternative to Docker. In fact, Kubernetes uses Docker engine to run Docker containers. Kubernetes is highly scalable compared to Docker Swarm, a container management software from Docker. Kubernetes supports up to 5,000 servers and 150,000 pods in a single cluster. Kubernetes also supports other containerization platforms such as CoreOS Rocket and LXC LXD. What are some of the alternatives to Kubernetes? Docker Swarm and Apache Mesos are competitors for Kubernetes. Docker Swarm is also an open source software, but controlled closely by Docker alone. Docker charges users with a fee for premium features. Scalability of Docker Swarm is very limited. It supports only 1000 nodes and 30,000 pods in a cluster. Apache Mesos is again an open source software. It is also a cluster management software typically used to run and manage distributed data services like Hadoop, Kafka, and Spark. Apache Mesos supports native Java applications and Docker containers. Benefits of Kubernetes. Kubernetes can automatically scale up or scale down containers based on the CPU usage or based on the user request. Kubernetes keeps track of the utilization of each server in a cluster so that it can evenly distribute the load between all the servers in the cluster. Kubernetes has the self-healing capability. It keeps an eye on the running containers and automatically restarts them when a container fails. It rolls out software updates to running application containers on a live production system. If there was any problem found in the upgraded application software, Kubernetes can roll back to the previous working version in just a single click. It handles server maintenance by automatically moving containers away from the server undergoing maintenance. It provides high availability by distributing containers across many different servers. Also, when a server fails, Kubernetes automatically recreates those containers that were running in a failed server in a new set of servers. Kubernetes at a high level. Kubernetes abstracts the underlying infrastructure for the end user. It provides us with a simple API at which we send our requests. For example, it is as simple as requesting, "Hey Kubernetes, spin up 4 containers of image X." Kubernetes will find underutilized nodes in a cluster in which it will spin up the new containers. Users have to just specify their intention in a YAML file. Kubernetes will convert the user intentions in the YAML file to manifestations in the cluster. The API server running in the Kubernetes master node will talk to other agents running in the worker nodes to bring the current state of the system to a state the user intends to have. Kubernetes building blocks. Kubernetes cluster management involves master node, worker node, and kubeadmin CLI utility. Kubernetes container management involves pod, deployment, service, and kubectl CLI utility. We will discuss in detail about these building blocks in our next video lecture.